Yes, sir. Good morning. Yes, audible.
Good morning, everyone.
Morning, sir.
Let's start by recording. All right. So just give me one more minute. We'll start. We'll see. Okay. All right. So we are good. So guys, anyone have any questions regarding the previous sessions, what we discussed yesterday? We discussed how to build the very new firewall and how to take the console access, how to take the GUI access, how we can check some dashboard stubs, right? If anyone have any questions, please feel free to ask. This is your class and you are eligible to ask anything which you feel I need to understand. Okay. Meanwhile, let me log in my firewall. Lokendra, you able to understand in this batch?
Yes, sir.
Any problem? All good?
No. Yes.
Okay, good. All right, guys. So once again, welcome you all in the session. And thanks for joining. And let's start our module one. That as per our commitment, because we have some basic foundation. We done the initial configurations, right? How to build the firewall access for the CLI, for the GUI, and how dashboard is going to look like. At least you guys have the basic foundations. So let's start some theoretical steps. So we are going to start this module. That is a very first module. And in this module, we are going to discuss what is the single pass architecture and what is the flu logic. That's two topic we are going to discuss, right? So first we'll start with the SP3 architecture, that is known as the SP3 architecture, and followed by it we'll start with the flow logic, means packet flow, how the step-by-step packet flow is going to be happen. Okay, so you guys are ready for that? You need to digest a lot of theoretical stuff. I know this is flow logic, especially going to be a little bit complex initially, very first time when you're going to understand and discuss the concept. But subsequently, when I just explain and break down the every packet later in the different detailed topic, it is going to be easy for everyone. Okay, so you don't have to worry about that. Ayappan, any questions you have before I start? Are you good, Ayappan?
Yes.
You question any have? I think you unmuted yourself.
Yeah. Okay. No, it's not. I need
All
to.
right. So let's start, guys. What is SP3 architecture in the Palo Alto Firewall, right? So when you go for any interview, trust me, this question is always going to be asked. What is the SP3 architecture? Okay. And if you are not able to explain about the SP3 architecture, it is very difficult to crack the interview. 99% chance is there when you go for the interview, they are going to ask, what is the SP3 architecture? So first of all, let me break down the SP3 component. So SP3 is a word which is associated with the first S is the single means, and P3 means the first P is the pass, second P is the parallel, third P is the processing. So that's why single pass, right? Parallel processing. So that's why 1P, 2P, 3P, it's become the SP3 architecture. So this is the full form of the SP3 architecture, right? So SP3 is the single pass parallel processing architecture. And what does mean single pass with the parallel processing architecture? That I have to explain in my layman language. So you'll understand. Just hold on for a second. Okay, I'll explain. But let's understand what they are saying as per the ebook, right? Or might be the PPT. So they are saying Palo Alto network have a next generation firewall. You guys know why it's a next generation firewall? Basically based on the unique feature that is the single pass parallel processing architecture. Means this Palo Alto firewall are very unique firewalls, right? and they have the unique features that is a single pass parallel processing. And by using this single pass parallel processing, what benefits we are going to get? That is going to give you the high throughput, low latency network security. Means when the packet is going to process through the firewall, right? You are going to get a lot of packet and you are going to get very high throughput output, right? High throughput means whatever the packet you are getting from the LAN, it is going to process very fastly and it is going to get means get sent out from the your egress interface. So this is your egress interface, that is your out interface, and this is your ingress interface, that is your input interface. So whatever traffic you are receiving from LAN and you are sending to WAN, that is you're going to be calculate how much time you holding the packet within the firewall. So if you're not holding the packet so much long duration within the firewall, definitely your throughput is going to be high. Let's take an example how throughput is going to calculate it. Let's suppose there are a lot of humans are here, right? And they have to cross a gate. They have to cross this gate, right? This is, let's suppose, a gate. So how many people are crossing this gate within a 60 seconds? Might be the 5. So this capacity might be low, but let's suppose I'm going to make a 50. So this is the low high throughput, means the throughput is going to be low because within the 60 second you're just passing 5 people. But within the 60 second, if you're passing the 50 people with the same gate, that throughput is going to be high because how much time you're taking to just cross the channels. Low latency, definitely if you're going to pass the packet very fastly, then your latency is also going to be very low. You means you're going to keep the packet within the firewall is very low time duration. That's why if we are going to use the SP3 architecture, my latency is going to be low, right? And my throughput is going to be high. Means overall processing is going to be too fast. So Palo Alto networks solve the problems that plague the today's security infrastructure SP3 architecture, which combine two complementary component. Means it is going to help to solve the today network problem because they have two unique feature. By using that, they are going to use the SP3 architecture. The first is single pass software and the second is the parallel processing architecture. So what is single pass software? That is your PAN OS. PAN OS means your iOS, right? So this could be the 9.0 iOS. We have the 10.0 iOS, and even I am using the 11.0 iOS, latest one, right? So most of the company you're going to find either 9.0, that's quite old. 10 was quite new, very new, or might be some cases you are going to find the very latest at the 11.0. So these are the PAN OS on which you are going to process the packet whenever it is going to receive by the Palo Alto Firewall. So this is my PAN OS, and after that, this PAN OS, what is going to be happen? If once this packet is going to be there, your hardware is also going to play a very vital role. Means software is there. This is your software, but also you require the hardware. So the firewall have the hardware. What is the hardware? That is your RAM. The second is might be you have the CPU, that is central processing unit, right? You might be going to find the ASICs also that is going to connect. So this kind of the hardwares you're going to get like chassis, modules, SFP, lot of things are there, but most of the case like processor are there and RAMs are there, like hard drive is also going to be there. That is a hard drive, means how much storage you have. So these are the hardware. So in combination of this software and hardware, that's why SP3 when you're going to use, they're going to use the processors, they're going to use the RAMs, they're going to use the hard drive, they're going to use other hardware plus along with the PAN OS software, and together they are going to help you to do the high processing capacity when the packet is going to land to the Palo Alto firewall. That's why it's single pass with the parallel processing. So parallel processing means with the help of the hardware, the parallel processing is going to happen, and the intelligence of that packet is going to happen with the help of the single pass software. Any doubt in this slide till now? Or shall I go and explain the layman language, how it is happening? Anyone? So let me go and explain something real-time example so you guys can understand what is that. So let's take an example. This is my one of the examples I have taken from the internet. How basically this parallel processing is going to happen with a single pass software or might be the parallel processing hardware. So just take an example. You are at the airport or Indian metro stations or might be any shopping complex or shopping mall, and you are just going inside of the railway station, airport, or might be shopping mall. You yourself have your own posture on body, or might be you're going to carry some kind of the baggage. It could be any scenario. Let's suppose you are at the airport and you have to cross the channel. These people are here. So very long queue are here, right? Different people are here, and here is one of the security personals who is responsible to check when you're going to cross this channel, right? So might be, let's forget about for time being, there is any kind of the scanning channel available. So these people have some baggage, right? Everyone have some baggage, means some packet. They have the suitcase attached with them. Some are not have the suitcase, some are have the suitcase or briefcase or might be other baggage, right? So they are just, going to carry different items, and they're trying to just cross this particular channel. So if this is the manual scanning is going to be happen, so this security personnel who is just standing behind this gate, he need to scan your body. That is the first case. And after scanning your body, they need to scan your baggage, means your packet as well. Whatever the packet you are just carry, that is also going to scan by the that particular security personals. So in this scenario, if it is going to be happen, it is going to take a time, because might be he need to open your baggage and it is going to check what is inside of your baggage, right? Might be your baggage having a clothes. This could be the clothes. You have some water, you have some kind of the liquid, some medicine, some chemicals, could be anything, glasses. You might be having some kind of the other material of food you might be have. So it could be any item, and all item must be scanned before it is going to pass to the channel. So he will take almost 5 minutes or might be 2 to 3 minutes to just scan everything. So if I have 100 people on the queue, so just think about, let's take about 3 minutes average time. So they have to wait 300 minutes. So almost if you divide it 60 minutes, so almost it's going to be 4 to 5 hours, right? It's going to be 5 hours to just cross this channel if 100 people are there, because 10 people are going to take 30 minutes, 20 are going to be take 1 hour, and like similarly you have the 100, so that is going to be 5 hours. So you can think standing in a queue for the 5 hours, it's not a ideal situation for the people, right? Means you have to wait, you are going to be tired, you're going to be frustrated. So that's not a good case. So in this case, what is going to happen? Your throughput is going to be, right, very low, and your latency is also going to be very high, because you are processing very slow packets. So your latency is also going to be very high here, right? So that's not a good case. So let's do something alternate, and let's see how it is going to be game changer for you. So scenario is going to be same. Again, we have the different users who are coming, right? They're coming here. But what I'm going to do that, the packets they are carrying, I'll install one of the separate machine, and that machine is going to be responsible to scan those all packets. Means whatever the packet is coming, that is going to scan by the machine. So this machine have the different sensors. Let me install it. So I can install the sensors here, different sensor. So might be this is going for the food, this is going for the water, this is going for the chemical, this is going for any kind of the metals, right? This is going for the any kind of the poisons. Means different sensor are going to scan different thing. So I do not need to open this packet. I simply, this first user come, his packet I put in the queue. Second user come, I'll put in this queue. So their packet is going to be closed, boxed inside of this particular machine. This machine is going to, once the packet is going to reach in the center, let's suppose this is my center. So this machine is going to start scanning and it is apply all the sensor, sorry. It is going to apply all the sensor, all go on this particular packet. So your packet in the center of this machine, and this is going to apply all the sensor at a one time. So this all scanning is going to be happen. Here is going to be one display, one PC is going to be there. One security personnel is sitting here as well. He's keep watching what is happening. So packet is going out, and once it is going to out, the display is going to say final output, whether this packet having any kind of the bad food, any kind of the chemical, any kind of the guns, any kind of the metals, any kind of the unauthorized drugs, any kind of the authorized, any kind of the like any products could be there. So that all is going to be displayed. And if this people who is security personnel who is going to see the output, if he's happy, then only he is going to allow. If he's not happy, he will just stop you and ask to do the manual verification, right? So might be this manual verification is a separate process, but still other packets are keep moving and keep scanning, and you yourself are going to cross the channel and simply his scan your all body within a few seconds. You are going to cross the channel. So overall, in this situation, your packet enter once in this machine, and multiple sensor has been enforced their capability on the same packet, and everyone did the same result at the same time. Means if this sensor is going to take 1 minute, 1 second, this is 1 second, this is 1 second. So within the 1 second, your packet has been fully scanned and they get out from the system. That's the parallel processing. Means you're doing the multiple thing together on the same packet to just get out the result what is inside of my packet. Is it clear what is a parallel processing? Guys, is it clear what is a parallel processing? Did you guys understand the meaning of the parallel processing?
Yeah, yes.
Okay, it's clear, right? So same concept Palo Alto is going to leverage. So let me go and explain the Palo Alto analogy so you guys can little bit understand. Just give me 1 second. So now let's back to this slide again. And let's say, so let's suppose we have this slide. Let me use a different color. So let's suppose this is my Palo Alto Firewall. Let's suppose this is the one CPU and we have the different CPU. Okay. Your packet is going to hit here and going to out from here. This is your CPU and this called as a master CPU. Just take an example. This is a child CPU. These all are side. These are CPU again processor, but they're the child CPU. This is for the layer 2. Means this is going to verify the MAC. Just take an example of networking. This is go for the layer 3, the IP. This going to verify your applications. This going to verify, let's suppose, IPsec. This going to verify, let's suppose, content. Take an example. This is going to verify for your any kind of the user ID, right? So we have the different CPU. They have the different role, right? And once packet is going to land, then different CPU is going to be activated for different actions. So take an example. Let's suppose this packet is going to land. This is the IP packet, okay? This packet is going to punt on this interface. This interface, Ethernet 0x0, and this is known as the ingress interface. Okay, that's known as the input interface where the packet is going to be land. This is my, let's suppose Ethernet 0x1. This is known as the egress interface. That is the output packet. So this is my input, this is my output. Now, once the packet is going to be land, okay, listen carefully, guys. This packet having a lot of information. What is information? This packet could be, this could be have the IP address. This could be have the MAC address. This could be have the your port number. That is the port details. So this is your layer 3. This is the layer 2. This is the layer 4. This also have the applications. That is the layer 7. This have some user ID, right? Additional information that they have the content. So this packet have the lot of information. This packet is going to punt on this master CPU. Then master CPU is going to delegate different tasks to different sub CPUs. Okay. So this is his responsibility. So let's suppose for layer 2, he is sent to this. For layer 3, sent to this. For layer 7, sent to this. For let's suppose application IPsec, that's it's sent to this. For content, they send to this. For user ID, they send to this. So means different action has been performed for the packet for different CPU. So this is going to take 1 second and it will submit the output. This is going to take 1 second, submit out this. 1 second, 1 second, 1 second, 1 second, 1 second. Means every action is going to happen for the 1 second. Means this all processing, layer 2, layer 3, user ID, application ID, content ID, IPsec. Means every action is going to be happen and then finally packet is going to be out. So that's the parallel processing. Means packet is punt to the firewall and after that it just process and it's sent to the output and then it is going to send to the your next device which is connected to the firewall. This is the parallel processing. That's why you can see in this we have the policy engine, we have the application ID, user ID, content ID, networking, control plane, data plane, hardware and single pass software. This is the PAN OS. These all are working and based on that working, my packet is getting captured and it is going to be analyzed. And after analyze whatever the policy need to be enforced, that is going to be happen. And then finally packet is going to be out. This is known as the parallel processing, guys. Any questions or we are good till here? Batao, any question anyone have or we are good?
Hello, Vishal sir.
Yes, yes.
Yeah, like if someone is saying like I'm facing some latency issue because of, yeah, they are saying that latency is because of the firewall.
Can you
But
just
we
speak a
know
little
there
bit
is,
louder, Chandu? Your voice is a little bit low.
yeah. If someone is telling I'm facing latency issue, we know there is no latency because of this firewall. Like how we can show them like in the logs or any type, this latency is not because of the firewall.
Yeah, I'll show you later latency. We have the multiple way to troubleshooting, right? We can check the live logs, how much packet is going to hold on the firewalls, right? We can take the packet capture. We have the debug options, right? We have the SSE command center who is going to give the real time, like how packet is processing, how latency is happening, how the drop is happening. So that is the next step I'll show you once the configuration is going to be started, okay? But for
Yeah,
time being,
okay, sir.
we're just trying to explore the packet flow and the SP3 architecture, okay? I'll explain later on. No
Okay.
worry. How troubleshooting is going to happen for different use cases. We have the multiple scenario. Latency could be due to the multiple region. Okay. Any other questions, guys, regarding this? Or we are good? All right. So let me move, guys. Let me go and little bit summarize more in different way. Hold on. Okay. So now in the same process, if you go and learn the Zscaler, the same thing that is known as the, in Zscaler, it is going to known as the single scan multi-action. The action is same, right? Means the process is going to same. If you're going to become a Zscaler engineer, they have the process that is known as the SCMA. That's the short name, SCMA, right? They known as the SCMA. It's equal to SP3 architecture. Just name has been just single scan multi-action. Single pass with the parallel processing. Means again the process is going to be same. Once the packet is going to hit in the memory, URL filtering, antivirus, botnet, like cross scripting, DLP, DCC, means every action full inspection is going to happen once packet in the memory, and one go result is going to be out. And earlier it was happening one by one. This is a traditional, means if it is going to check 1 second, 1 second, 1 second, 1 second, the 4 second is going to be required to just full processing the packet. That is a service chaining concept that was used earlier. But now that is a SP3 architecture. In the Palo Alto, Zscaler have the SCMA architecture. With the help of that, you can just do the packet processing very fastly. So this is a new technology, guys, trending how the packet is going to be inspected very fastly. Okay. Now, let's break down that architecture with the hardware level. So that's why I'm saying in this Palo Alto Firewall, we have the one of the control plane and one is a data plane, right? So that's why I have referring the master CPU and we have the some child CPU. So because the packet is always going to hit, so they have the dedicated control plane and that is going to further like allocate the different hardwares and different kind of the signature matching engine CPU to just process the packet. Let's suppose my packet is there in the firewall, right? And this is going to further route the packet for the any kind of the network related signature checks like IPS engine, virus, spyware, any other signature I want to check. So this processor is responsible. This is my signature match processor that is going to responsible. If I want to match the security processor, let's suppose I want to check the SSL, IPsec, I want to do some kind of any decryptions, then it is my security processor are responsible. If I want to do any networking stuffs, let's suppose QS, route map, MAC lookup, NAT, then it is the network processor. So they have the different hardware, they have the different kind of the checks going to be happen, they have the different CPUs, right? Different RAMs, and they are going to perform the different action for the different packet which is going to receive. So this is how, and they all are connected with the 10G buses. So they are just interlinked each others, right? But they have the control plane and data plane. Now, one of the very unique feature in the Palo Alto Firewall, guys, if I want to discuss with the control plane and data plane, let me go in the firewall. Very unique feature in normal routers and normal switches or even the normal firewalls, right? You are going to find, let me put this in top. You can see we have the one is a management plane CPU and one is a data plane CPU. So this management plane CPU and this data plane CPU are very unique in the Palo Alto. This is just doing the management stuff. And if this is going to down, still your data plane is going to work. It is not going to affect it. If my data plane CPU is going to be down, still my Palo Alto management plane is going to be there. So in layman language, you can understand if data plane CPU is died means down, it's a dead means you cannot do any packet forwarding. Means your data traffic is going to be dead. So still you able to log in the firewall. Means you can do the troubleshooting, you can fix that, where's the issue and how I can fix why this data packet is dead and why data plane CPU is dead. So still we have a lot of things where by using that you can just get this all sorted. In reverse direction, if this is going to be down, you can't log into the firewall, but still your data is going to be processed without any problem. So there are two CPU that is available, but in Cisco router or switches, if you just go here, they have the, if there's a router, this is the switches or any router, they have the single CPU, central processing unit. And if this is going to be down, entire box is going to be down. Means your data plane is going to be down, your control plane is going to be down. But in Palo Alto, it's not a case. One down, means your management is going down, still data is going to work. If this is going down, then your data is down, your management is still going to work. So let me break down in the more detailed way how this control plane, data plane is going to be look like when you're going to use the SP3 architecture. So see, this is my another slide. So you can see here, we have the control plane, the processor I showed you right away. In this particular, this is my control plane. So let's understand what is the use of the control plane. So probably it is going to ask in the interview, so you should be ready about it. So if I just discuss about the control planes, the control plane are responsible for few tasks. Like if you want to do the management of the firewall, you want to do the configuration of the firewall, and you want to do any kind of the logs fetching from the firewall and reporting of logs. Means 4 action you can do that. Means all are related to management. Means control plane is just managing the firewall. You doing any configuration that is going to happen from the management plane. If you want to pull the log, that is going to be happen from the management plane. And if you want to get the reports from the firewall for your any kind of reporting purpose, that is also going to happen from the your management plane. Is it clear? The 4 actions, sorry, the control plane and management is same, but this is the control plane responsibility. You guys note it down. It's clear, everyone. Give me thumbs up if it's clear.
Yeah, Vishal sir.
Okay.
Hello.
Yes.
Sir, how this management plane and control plane connected inside the firewall? Like physically, is there any connecting or like?
No, you don't have to do. They are just design architecture. You don't have to do any configuration. We just have to enable the policy routing. Then it is going to be automatically activated. You don't have to do anything. Okay. This is the iOS feature, software feature. Means in router, you never do the control plane configuration. It is by default the hardware, na? Like you purchase
Yes,
a
yes.
mobile CPU, it's going to be inbuilt. You do the CPU configuration, no, it's always going to come with the hardware, right? So you don't have to do about
Yes,
that.
yes.
It's the provider OEM vendor responsibility to build the very good, processors, and they install that in the hardwares. So that's not your responsibility. Your responsibility is just managing, configuring, and troubleshooting. Okay, Chandu?
Okay, sir.
Okay, so moving next, we have the second feature that is known as the my data plane. Okay, so this data plane is basically more responsible for 3 features I showed you just in diagram. One, they have the security processing, security matching processors, security processors, and network processors. These are the quite confusing, but you have to understand carefully. If I'm talking about a security matching processor, this is all about the signature matching. Means any vulnerability, any virus, any anti-spyware, any kind of the DOS attack. So that signature is going to be checked here, and signature matching is going to be happen by the help of the security matching processors, right? But if you talk the security processor, this is going to handle a task like IPsec, SSL decryptions, anything like encryption, decryption, you want to do that, that is going to happen with the security processor. These are the 2 things. It's more about the content inspections, right? And this is more about the tunneling concept protocol if you want to do that. That's the 2 things you have to understand. Clear? And the third is the network processor that is responsible for the routing, NAT, QoS, route lookup, MAC lookup, and network layer communication. So data plane is responsible for these 3 tasks. Basically, you want to do any kind of the data scan, then data scan is going to be happen with the security processor. You want to build any kind of the encryption tunneling concept, GRE over IPsec, you want to build any kind of the encryption, SSL VPN, then this is going to use. If you want to do any networking, then it is going to be happen with this. So this is the full concept of the SP3 architecture, guys. Please let me know if you are happy, because I need to move to the second topic. Any questions, right? This is like how the parallel processing hardware, the same thing I explained, signature match, a spyware, data plane, control plane, right? This is how the packet is going to come. Different action is going to be happen for different signatures. So this is all about the single pass software is going to scan and do the actions. Batao, anyone have any questions, guys? Or we are good? We are able to move next topic. Because I just explained the SP3 architecture. Now it's time to flow logic, guys. Okay, let me stop this recording and we'll move to the next topic. I'll start the recording again. Now, we understand what is the SP3 architecture. Now it's time to understand how the flow logic is going to be happen. If my packet is going to hit to the firewalls, how firewall is going to be have with that particular packet. That's the flow logic. Okay. So let me open it. So let's take an example. Just take an example. Very first time when the packet is going to land to your Palo Alto firewall, how your Palo Alto firewall is going to take an action. So let me draw some. This is a PA01, your firewall. They have one interface. This is E0 by 0. This is your another interface. This is E0 by 1. Any packet which receive and punt this packet, this is known as your, again I am just repeating, ingress stage. If the packet is going to out, egress means this is my input, this is my output packet. So this is my input, this is my output. Means you receive the packet, you transmit the packet. Ingress, input, receive. The all are same. Egress, output, transmit. It's all are same. So you can use either word. But in this slides, you're going to find the ingress stage. And if you go below, you are going to find egress, forwarding stage, or might be transmit the packet. So that's why I just explained. So you can understand what I'm going to use the term. So you don't have to be confused. So packet ingress means packet is just received by the Palo Alto firewall on certain interface. Packet egress means the packet has been sent out from the firewall with the certain interface. Clear? So let's suppose this is my first packet. Let me use some different color. This is my first packet. Sorry. Let me draw something. Okay. So we have the, basically the packet have the source MAC, destination MAC, source IP, destination IP, source port, destination port. You have the applications, some additional details, and then you have the data. That is the payload. So this is your packet. In this packet, we have the different informations. These different informations, this is basically known as the layer 2 information. This is known as the layer 3 information. This is known as the layer 4 information. This is the layer 7 informations. I'll discuss, this is some other informations. I'll explain what is other information when I just show the policy and all. And finally, we have the content. That is the content. Means that is the payload of the packet, actual data, which you are going to send over the firewall from one source to another destination. So this kind of the information is going to receive. This is your IP packet. that is going to receive by the firewall. So once this firewall is going to receive the packet. Let's suppose this is the firewall. This firewall is going to receive the packet. This packet is going to receive by the firewall interface. Then what is the first step firewall going to do with this packet? That we have to understand, guys. Means once my packet has been received, how I'm going to take actions. So for that, we have to understand this ingress block. So you can see the very first stage, when the packet has been received by the Palo Alto Firewall, the Palo Alto Firewall is going to extract some informations. And you can see this is going to be do the extractions for your layer 2 information, the layer 3 informations, and the layer 4 information. Means this is your complete packet. Out of this complete packet, they are going to extract your just 3 informations. And based on that, it is going to be take some actions. So what action they are going to take? The very first action, once they have extracted the packet, they are going to check what is the zone associated with this particular packet and which interface I received the packet. And the third thing, the packet which I receive, it's a fragmented packet or unfragmented packet. So let's understand one by one. This we understand. This is going to extract, means the packet is going to be received by the Palo Alto Firewall. Out of that packet, they will just get the information for layer 2, layer 3, and layer 4. And then after, it is going to check which interface the packet has been received. So they might be going to find the interface name. Let's suppose this is my ATS 0/0. And then they are going to check what zone configure on that interface. Then what is the zone? We have to understand. So take a special note here. In Palo Alto Firewall, if you are going to create any interface, it's a layer 2 interface, layer 3 interface, tap mode interface. I'll explain this all. vWire interface, VLAN interface, sub interface, right? In all scenario, you have to create one zone. This is the unique feature. So I'll explain what is zone later on. This is the part of our content. But every interface except HA. HA interface doesn't require zone. No required zone. But rest other interface, layer 2, layer 3, tap mode, vWire, VLAN, sub interface, tunnel interface, that all required zone. So you have to mandatory configure the zone for every interface. That's why zone lookup is going to happen. This zone could be the trust zone, untrust zone, LAN zone, WAN zone, inside zone, outside zone, DMZ zone, could be anything. We'll see how it is going to be configured. But for time being, make a note, every interface should have a zone, and that zone lookup is must. Did you guys understand this line? It's a clear packet. This it's clear for the everyone, guys. Give me thumbs up if you understand till here. समझ आ रहा है? Can I get the acknowledgement? Everyone is understand till now. Okay, good. I have the good acknowledgement. Very nice. Bharat, you not able to understand? I didn't find any acknowledgement from you. Okay. Bharat, you able to hear me? So guys, this is how the third step completed. Means the packet received, extractions happens, ingress, zone lookup done. Now the fragmentation. Fragmentations is a process. Let me clear the screen because we understand. Let's suppose we received any IP packet. Let's take an example. This is my switch. Okay, switch connected with the Palo Alto Firewall. This is another device. Let's suppose this is another switch. Every interface by default, they have the maximum unit which is going to be take on the interface. That is a 1500 byte as a MTU site, right? Maximum transmission unit. Let's suppose we get the packet as a 6000 byte. So this switch is going to be fragment the packet because it is not going to be take, or might be this switch itself is sending the 6,000. So this firewall is not going to accept the packet. It must be fragmented, then it is going to be accept. So let's suppose for some reason I just split this packet in 4 packets. So this is going to be fragmented. The packet has been divided. So if the packet is going to receive by the Palo Alto Firewall, because earlier we have the 1 box, but this box has been divided in the 4 box. So they will reassemble the packet and it will try to see what is the actual packet size and what was the actual information. So that's why you have the reassembly process also here. Means if fragmentation was happen for that particular packet, then they are going to be reassemble that particular packet. That is also going to be happen on the ingress stage, guys. So this is the second stage of the packet processing. Clear? Now we have to move the further stage. Now after this all checks, packet is going to stay still in ingress stage. Still the firewall not put the packet inside of this firewall stage. Still the packet is here in the very first stage. Now it is going to check the further verifications. It is going to check the packet which I received. I extracted the information layer 2, layer 3. I did the reassembly. I checked the interface. I checked the zone. But is the packet is valid packet or the packet is invalid? Means how it is going to be decided. So invalid is basically always going to be discarded. Means the packet having the error, they will not eligible to further processing. So what are the conditions on which my packet is going to be valid or invalid? So let me go down. So if you have the any kind of the packet problem, this could be the issue. Means if you have the any mismatch IP header, then your packet is invalid, Ethernet or IP header. If truncated IP header, means by default 32 bits are there in the IP packet, but let's suppose you're sending the 30 bits or my 28. So that is going to be not eligible. That is going to be drop. Any packet have the protocol number 0, that is also drop, not a valid packet. TTL 0 always going to be drop, not is basically valid. Land attack, that is your DOS attack, right? Ping of death, again, it's a ICMP based DOS attack. Means if any kind of a DOS attack is there, that is also going to be drop. Martin IP address, the IP address which doesn't exist in anywhere in the universe, means invalid IP address. That is also going to be drop. Any kind of checksum error IP, that is also going to drop. Means either of the condition is going to match, the packet is going to be dropped on the very initial stage of the firewall processing. That is known as the your IP errors. Means anything is going to bad here. That's why you can see here ingress process error, means anything is going to bad, then it is going to drop. Now if everything is good, then your packet is going to move further stage. Okay. Now in this stage, it is going to check the packet which I received, does it required any firewall inspection? So now you have to understand what does means firewall inspections. Anyone know what is a firewall inspections? Have you heard? What is a firewall inspections?
Yes, sir.
Yeah, can you just explain?
It was the packet, it was the teach me inspection, what was the content inside supposed to, for example, it was filter the ULR.
Very
like,
nice. Good, good.
all
What
the,
else?
it was checking for the every website, supposed to we can filter the packet. There is two modes. The one is non-inspection, or another one is the infection mode.
Okay, good entry. So yeah, you're right. So inspection means, let's suppose in router, what happened? Let's suppose this, we have the one of the router. Packet is going to receive. Let's suppose this is my G 0x0 interface and this is gig 0x2 interface. My one packet is going to receive here. So they just do two things: layer 2 verification, layer 3 verification. So simple packet we're going to check, and simply it is going to be switch out based on the routing. Basically based on the routing. Layer 2 also not going to check. If there is a L3 switch, then it is going to happen. Then your packet is going to be. So this is just simple packet is going to be forwarded switch. That is a non-inspection mode. Means it will just check the IP headers. What is my source? What is my destinations? And based on that, it is going to check and send the destination packet to the desired interfaces. That is a non-inspection. So similarly, if your inspection is no, so your firewall is also going to do the same stuff. Means the packet is going to receive, it will check the routing or layer 2 and it will just send to the out. No further checks is going to happen. Means it is not going to check your applications, content, user, port, nothing is going to check. It's simply going to work as a layer 3 router, means layer 3 switch or router, and the packet is going to be sent out. Simple from ingress to egress. You can see this line. Follow this directly. If no, then it's simply packet is going to be out. But if you are want to do that non-inspection, then why you want to use the firewall? That use of the waste of your money. Okay. So in 99% case, 99.9% case, your inspection is always going to be applicable. Means you have to do the verification for all the IP packet which you receive on this interface, right? So in this scenario, what is going to be happen? My inspection is going to be yes, means this is going to do the layer 2, layer 3, layer 4, layer 7, URL, content, user ID, and etc. So means everything is going to be must checked, right? So that's why inspections. Clear? Now, the last stage of the packet, everything is checked. Now it is going to check the packet which I received. That's the plain text packet. Or it's a IPsec packet. That is going to be checked. So it is going to verify it's a plain text packet or it's a IPsec packet. So if it is a plain text package, means everything is non-encrypted. Means the encryption is not there. Means the packet is non-encrypted. So it's a plain text, so it is going to move the next stage. But if it is encrypted, so they will use the decryption engine, which is available in the Palo Alto Firewall, and they first do the decryption because it's the encrypted packet. Firewall will not able to understand what is inside of the packet. Only they will understand the header details, but not the all information of the firewalls. So for that, we have to do again IPsec decryptions, and based on that decryptions, we have to convert the packet again in plain text, and then the whole process is again going to be started. Again from here, again packet is going to come here. So all checks is going to happen. Now this time the packet is going to receive as a plain text. Then it is going to move the next stage. So this is the difference between the plain text packet and the your IPsec packet. So now if everything is good, then your packet is going to move in this block. Now you guys tell me any question in the ingress stage, or we are happy with this particular all concept. We all are happy with the ingress stage blocks. Everyone okay? I need acknowledgement. If all are okay, give me thumbs up. Right?
Sir, how to
Yes.
check one small question, sir. Sir, how to check discard packet, sir?
How to check?
Discard packet.
Or discard packet means you have to allow the packet capture. Then you are going to check that only.
Okay.
You have to enable the I'll show you how to enable the packet capture later. Okay. So this is not going to be logs because it's a very initial stage. So you have to do the pre-press match checks. And then after you can only check your discard packet is available or not. All right.
Okay. Okay.
Any other questions?
सर IPsec के थ्रू जाएगा तो ये encrypted होगा, right?
Yes, IPsec is encrypted. IPsec packet always encrypted packet.
Okay, तो normal packet सर क्या मतलब without encryption packet का flow करेगा?
Yeah, there are packet ना. Sometime we let's suppose आपकी company है. Let's take an example. this is your one branch, right? And this is your another branch, branch 2. और आपका यहाँ फारवल लगा हुआ है. Let's suppose this is the firewall, this is the firewall. आप यहाँ पे FTP कर रहे हो. So this FTP packet is like non-encrypted packet, right? So in that case, the plain text, na? Traffic is going to be plain
Yes.
text. So this is if you're going to telnet, right? This is again a plain text. Makes sense?
Yes, yes.
If you're doing the SSH, then it's a secure packet. So you have to do a decryption. If you're doing the IPsec packet, you're building the IPsec, then you have to do decryptions. So it's depend. Most of the case packet are going to be IPsec because you have to build the IPsec side-to-side VPN. That's why decryption is always going to be there. But some scenario, if you're just sending the plain text packet like telnet, SSH, non-secure port-based communication, HTTP-based communication, then it's not required the decryptions. For that, it is just going as a plain text. Okay, Loken?
Yes. Clear. Thank
Okay.
you.
Welcome. और किसी के पास कोई questions coming in your mind? No? Okay. So now moving to the next, and we have the next stage that is known as the fast path. So this is again one of the stage you have to be very careful while doing the understanding because it is going to be asked during the interview process, the difference between the fast path and the slow path. So anytime when the packet is going to process from the ingress stage, it is going to always land in the fast path. And then it is going to be decided, it is going to stay in the fast path or it need to be processed through the slow path. So that's we have to understand. So you think if this is my firewall, right? Because this is the next generation firewall, any new packet is going to land to the firewall. It will go in the fast path and it will try to check, do we have the session or not? So if packet is land in the fast path, this is the packet and the firewall session lookup is going to be checked and it is going to check, do we have any session or not? So if my new packet is there, definitely very first time is going to come in the firewall, there is no session. But if the packet is going to second time hit the firewall, there is a session. So this is a difference you have to always think about the slow path and fast path. Means if I have a very new firewall, that firewall have the very first packet, definitely they do not have the session. Session is going to build once the first packet is going to be processed. So if there is no session, then it will send the packet in the slow path and it will ask to create the session. So slow path used to create a session for the new packet. Again, I am repeating, if my very new packet is going to come, and based on that new packet, if my packet receive in my fast path, it will check, do you have any session, existing session available for this particular packet? The answer is no. Then it will send the packet in the slow path and it will ask to create a session for that particular packet. But if my packet is old packet, then definitely they have the existing session, solo path already created. Then it is going to stay in the slow path. It will not send in the, it will stay in the fast path. It will not send in the slow path. इतनी बात समझ में आई सबको? Did you guys understand this statement? Everyone understand?
सर ये सिर्फ न्यू फायरवॉल के लिए एप्लीकेबल है, जैसे हमने कोई नया फायरवॉल डिप्लॉय किया
Any new packet, any new packet. I just give you example of a new
Okay.
firewall, but any new packet which is going to hit to any firewalls. If this is a new packet, then always it is asked to create the session because session will be not there in their database.
Yes.
Ayappan, Sairaj, Chandu, Anurag, Bharat, Ashok, everyone happy? Did you guys understand when the packet is going to slow path? Sairaj, can you just explain when the packet need to be sent in the slow path? Sairaj, you able to hear me?
Yes, sir. Sir, can you explain again? I didn't understand.
That's why I can see like you guys are not listening. Okay. Who is going to help to Sairaj? Can someone explain when the packet is going to send in the slow path? Anyone in the class?
So if there is any new packet landing to the firewall at the ingress interface, so first the firewall will check whether the session is available or not. If the session is not available, so that packet is moved to the slow path to create the session. And if in case there is a session, so packet will stay in the fast path only.
Very good, Anurag. Appreciated. Sairaj, you understand now?
Yes, sir.
Can you just say in your words, because it's going to be asked in the interview, that's why I'm forcing this question again and again. Can you just explain in your word how it is going to be explained during the interview process?
If packet is moving from ingress to fast path, that time it will check each session is available or not. At that, if session is available, it will move in a fast path, and if there is session is not available, that time it will move to slow path.
Good. I really like that. Appreciate it once again. Thank you, guys. So I like this kind of the commitment. Everyone should have the proper notes and they keep writing the everything. Now, let's take an example. My packet is very new and it's landed in the slow path. Okay. Then what is going to be happen? Now, one more is going to be asked during the interview. If my firewall is going to receive a packet, it's either new or old. Which state firewall is going to be land that packet? It's a fast path or slow path? Who is going to answer that? If firewall is going to receive a packet, any packet, it's a new or old, which path it is going to land very first time on the firewall packet? It's a fast path or slow path?
Fast path.
Fast path.
Yes, that you always have to think, okay? Never give the answer, it's going to be slow path. Slow path decision is going to happen after landing in the fast path, whether I have the session or not, but always packet is going to land in the fast path. Okay. Many people always go in the interview and say, hey, no, it's a new packet, then it is going to be slow path. But no, it's wrong answer. It is always going to land in the fast path. Fast path take a decision, it's a new packet or old packet. Then it is going to send to the slow path. Make sense? So now let's suppose your packet is a slow path. I mean, your packet will be in the slow path. Then what is going to happen? Once your packet is going to land in slow path, always going to check three things. Okay. The very first thing is the routing. Second thing is your NAT policy. And third thing is your security policy. It is always going to check. Means the routing is very important, guys. Even you are going to become the firewall engineer. If you do not know what is the static routing, what is the dynamic routing, means like OSPF, BGP, then little bit being a firewall engineer, also you're going to face challenges. So that's why my recommendation, personal recommendation, it's not always forceful. Being a security engineer, also you should know at least CCNP NRC level of knowledge. If you are having that knowledge, trust me, you are going to get very good edge always in your careers. Even you are going to become a cloud engineer, you are going to get the BGP OSPF configuration. If you're going to become DevOps engineer, you're going to get such kind of the concept. Even you're going to stay in the firewalls proxy, this routing is never going to, away from its systems. It is going to be always there. So you have to use your brains to just configure. If you don't have the knowledge, then always you're going to struggle. So that's why routing is the very first stage. It will check the packet you received, do you have routes or not? If no route, then packet is going to be dropped. Then they will check their policy, NAT policy. Do you have the NAT policy or not? Not, then it is dropped. Then they will check the security policy, not, then it is going to be dropped. So that's why you can see the packet is going to in slow path, then the forwarding lookup is going to be happen, get the egress interface in zone, L3 route lookup, L2 MAC lookup, and then they will check the NAT. I will explain this again. There is a special statement. If destination NAT is present, then it will do the second lookup and do the real final ingress interface check. What does means? So once we start the destination NAT and NAT, then I'll explain this one. So you'll understand. For time being, you understand NAT, either the source NAT, destination NAT, it is going to check. If there's a destination NAT, the treatment is going to be a little bit different. Okay. So I'll explain. Then the third one, it's going to check the security policy. Then it is going to say the rule is available or not. If yes, then it is going to create a session. If not, then a firewall packet is going to drop in the slow path itself. Means it will not going to create a session. But if the session is going to create, the session is going to install in the your fast path. If the packet again going to come for the same, which I install, it will not go in the slow path. It will go and found the session because session was created and installed here, and it will go for the layer 2 to layer 4 processing here. So this is how slow path is going to come in a picture, and based on slow path, you are going to move in the fast path, and fast path is going to hold your session. Then it is going to check the processing. Means all processing is going to be do here, like your security rules, your NAT rules, everything is going to be checked. Now after checking, it will do further advanced verifications. Like we have the SSL decryptions concept, we have the application identifications, and we have the content inspections. These are the advanced things also we have to check as per the packet flow. So what is the SSL? You can see this is the next step. Once the packet processing is happen, we have the all session created. It will check does the packet require the SSL decryptions. So definitely we have to cover this topic. What is SSL decryptions in later stage? You can see we have the decryptions here. We have the all type NAT here. We have the zone here. We'll discuss, right? But if I want to discuss about the SSL decryptions, so what does means SSL decryptions? Let me just break down in the layman language. So we have the two type of the packets. One packet is the HTTP packet and another is the HTTPS packet. This is on the port 80. This is on the port 443. This is a plain text packet. And this is your encrypted packet. So this packet is going to be received by firewall. This is everything in the plain text. So no need to do any kind of the decryption and all. Because the plain text, everything is visible. So it will automatically inspect the packet. But what if the packet is going to come as HTTPS? It's a very secure packet. It's an encrypted packet, right? So encrypted packet is going to be there. Then the firewall will not understand what is inside of this packet. Means their data, their content, everything is going to be hidden. So such packets need to be decrypted. So that's why a decryption engine is going to come in a picture. So we'll discuss in detail, but always HTTPS packet is going to be an encrypted packet. For that, if you want to do decryption, then this decryption engine is going to come here. And this engine is going to help you to decrypt whether packet is valid for decryption or not. If it is decryption is valid, then based on decryption, it is going to be checked. See, here is another line you can find here. So SSL proxy mark session to be proxied, and then it is going to check based on decryption what application is there, what content is there. If the plain text, this is not applicable. But if it is not plain text, it's the encrypted. Then inside of the packet, we don't know what application user is accessing, what content user is accessing. So you have to decrypt, then you are going to find the application and content. And based on the application content, we can further do the verification. So let's suppose there is no decryption. For time being, you just forget about it. Let's suppose I'm receiving the plain text. Okay. So plain text, I know what application user are accessing. It's a YouTube application, WhatsApp applications, Instagram application, anything you are going to access, that is going to be always visible to you. So that all is going to be there. And based on that, you can figure it out what kind of application user is accessing. And then also you can see what kind of the attachment is there, what kind of content is there. So let's suppose your firewall is able to find the applications based on the application engine. But some scenario, if it is not able to find the application, what application user is accessing. So if application is identified, then it is going for the content inspection. But if some case not identified for some reason, let's suppose user is using such application which is not in Palo Alto database. In that scenario, it is going to move the packet in the advanced filtering, that is the application identification. And this is going to check some concept is there, application override. I'll explain what is that application override because we have to do the deep dive on it. Application ID. So I'll explain. I'll have to deep dive in the content ID. So I'll explain. But for time being, you have to understand application override means, do you want to not verify the application? Do you want to not check the applications? Then it is the application override is going to be there. Means you just want to just pass the applications. If it is yes, then it is going to check the directly security policy. If it is no, you want to check the application, then it is going to check the pattern based matching, which pattern is coming for this application, and based on that pattern, they will use the AI/ML and they will figure it out which category this application is falling, and they will just check the further application and then security rule. And based on that, it is going to decide this packet need to be allow or need to be drop. So if that is not matching as per your security policy, then it is drop. If it is allowed, then it is going to move for the further content inspections. The same thing. And based on that content inspection, they are going to do further verification. What kind of the virus, anti-spyware, malware protection means entire these things are going to be checked. Means antivirus, anti-spyware, vulnerability protections, data filtering, DOS protection, wildfire, everything is going to be checked. So this is how your content inspection is going to further happen, and entire content is going to be checked. And based on that content, finally, packet either need to be dropped by the firewall. If let's suppose their firewall packet receive which have the malware, then definitely that packet is going to be dropped by the Palo Alto firewall. If there is some kind of the bad attachment, data leak is happening, so definitely it is going to be dropped by the Palo Alto firewall. But in case it is not the case, then what is going to happen? It is just going to reach in the ingress stage of the packet, and your packet is going to be forward from the egress interface. If there was just an encryption was there, then it is going to be decryption was there, then it is going to be encrypted. They will apply the security profile. Apply security profile means the packet which you created. Sorry. So every packet, we have the security profiles. Means it's antivirus, vulnerability protection, anti-spyware, URL filtering, file blocking, data filtering. So this is all going to be applied. Based on that, it is going to be either allow or it is drop. Based on your actions, I'll explain how it is going to be created later on. So this all content is going to be happen. And finally, your packet is going to be in ingress stage and it is going to be forward. So if your packet was earlier IPsec, right? And it was decrypted and converted in the plain text. So again, while forwarding, you have to re-encrypt the IPsec packet and you have to send to the transmit. If it's the plain text, then it is going to directly send to the transmit to the exit interface. So this is how your all section is going to become. Your fast path is going to come, your slow path is going to become, your application is going to become, your content is going to become. This we have to do a deep dive again in the upcoming section. I'll just break down every sections again and again for the how the content inspection is going to happen, how you're going to apply the security profiles. I'll do the configuration, how you can send the alerts, send the packet drop stage, discard stage, how you can enable the content inspection, that how you can do the SL decryption, encryption process, that I'll show you in the later stage while doing the labs. But yes, this is how the packet flow is going to happen throughout the ingress to the egress stage. They have to land in the multiple blocks for the different checks, and then it is going to be final out from the firewall. Now you guys tell me any questions or we are good? Because I will explain now zone, because zone is very important. You see here, we have to know zone as well. So let me just explain the zone as well. What is the zone? Is it clear? Anyone have any doubt? Please let me know. Else, I will just jump. After this packet flow, I will explain the very important topic now. That is security zone. Because we discussed these two topics, flow logic and SP3 architecture. Sorry. So let me stop this recording and we'll just move to the next. Okay. Let's move to the next topic. And let's hold on, guys.